Hello guys, I am Kartika. I am going to tell you about HDLC and its frameworks. Then we move to the topic. First, we're going to see what is HDLC. HDLC means High Level Data Link Control. That means it is a group of communication protocols that is used for the purpose of transmitting data between the network points. Here, the network points may be point-to-point communication or else multi-point communications. Then HDLC is a bit oriented protocol. Then in data link protocol, data is organized into frames. Frame means nothing but it is also transmitted to the destination through the network layer for the purpose of verifying the arrival of the data, whether the whether the data sent is received at the destination or not. This acknowledgement will be given by using these frames. Then we move to the transfer modes. HDLC has two types of transfer modes, that is normal response mode and then asynchronous balancer mode. In normal response mode, it is used for the purpose of point-to-point communication as well as multi-point communication. But in asynchronous balance mode, it is used only for point-to-point communication. Then here in normal response mode, response is sent only from the secondary station and command is sent only from the primary station. But in asynchronous balance mode, the response and command will be sent from either primary or secondary stations. So here we call it as, but in normal response mode, in point-to-point communications, response from secondary and command from primary stations. Then in multi-point communication of normal response mode, the command is sent from one primary stations and response can be sent from one or two secondary stations. So here we call it as unbalanced mode. Then in asynchronous balanced mode, either primary or secondary station can send command and response, same for both. So here we call it as balanced mode. Then same, I am explaining you about normal response mode and asynchronous response mode. Same in diagrammatic representation is given here. Then we move on to the frame. I already explained you that frame means what? We are sending the frame to the destination through network layer for the purpose of checking the arrival of the data. Okay, same. Here we have three types of framing, that is I frame, S frame, U frame. First we see about the I frame. I frame means information frame. That is, it is used for carrying the user data. User data means the data will be given by the user from network layer. It is also used for flow error control informations. In iframe, the first two bits of the control field will be 0. Then in S frame is called supervisory frames. Here there is no information field like that. Then it is used for purpose of same flow and error control. Then here the first two bits of S frame will be 1 0. Then U frame is used for the purpose of system management. Here it is called unnumbered frames. The first two bits will be 1 1. I frame is used for user data information. S frame is used for control informations. Then U frame is used for system management informations. These are the purpose of framing. In I frame, first bit will be 0. In S frame, 1 0. In U frame, first bits will be 1 1. That's all. Then same here, diagrammatic representations. Flag, address, control, user information, FCS flag. These will be the fields in HDLC framing. Then in I framing, we already mentioned that it is for the user information. So here center we have the user information fields. S frame is for control information. So center we are mentioning control information. U frame we said that it is for system management. So we having here management information at center. Same, remaining all flags will be same. FCS means frame check sequence flag. Then we are going to see about fields of HDLC frames. Flag means it is a 8-bit sequence that that will be marked at the beginning and ending of the frame. In all frames, we seen that the beginning and ending will be marked as flag. See here, I frame have flag, S frame, U frame. All starting and ending will be flag. The pattern of the flag may be 0 1 1 1 1 0, like that. The pattern of the flag will be available. Then address field means it contains the address of the receiver. That is, if the frame is sent by primary station means it gives the to address. If the frame is sent by the secondary station means it will be giving the from address. This is the purpose of address fields. Then we move to the control fields. It is at 1 or 2 bytes. It contains the flow and control informations, error flow control informations. That is, it checks for the overflow or else error occurring or not. It will be controlled by the control fields. Then payloads means used for carrying the data. Here its length may vary for one to another network. Here and it is not fixed byte. FCS means frame check sequence. It is used for the purpose of error detecting. Whether the error occurring or not will be checked by this flag. Then we move on to the next field. Here we are giving the structure of the frames. In third diagram we are seeing that here flag will be 8 bits, address will be also 8 bits, control 18 or 16 bits. Informations is, we already seen that informations may be vary from one network to the another, so it is variable. Then FCS can be 16 or 32 bits, flag same 8 bits. This is the memory. Then we going to the information frame. That is, the first bit will be set to 0, second, third, fourth will be NS. NS means send sequence number. 5 will be pole or final bit. P means pole, F means final bit. If the bit is set 1 means final bit is set, that is F is set, and information is sent from the primary to the secondary station. Then if the bit is set at